Hello and welcome everyone. In this video I will tell you about how caustic is made in plants. So we have the following reaction of salt, NaCl, and we have water, and what is formed, NaOH plus hydrogen and half chlorine is formed. So for this we have electrolysis process, and in this electrolysis we have this membrane, and in this membrane only Na plus ions transfers from one place, from the anode side to the cathode side. So this is anode and this is the cathode. Na plus and Cl minus ions are formed, NaCl, and here we have H plus and OH minus. So Na transfers from the anode side to the cathode side via oxidation, and here reduction occurs. So what is the reaction of Cl minus? Two Cl minus ions combines to form chlorine and 2 electron is liberated. Similarly, hydrogen is reduced, and hydrogen H plus ion, 2 H plus ions combines with 2 electrons to give hydrogen. So this is a basic reaction. So in this video I will tell you about how what are the steps of caustic generation. So we have a saturator. Here we have from the top salt comes in, and brine from return brine tank comes in. So this is a 205 GPL concentration of salt which comes in, and from here the salt gets transferred, means salt is added, and this brine which gets formed is 305 GPL. And in this brine we have a lot of impurities. What are the impurities? We have calcium ions, we have magnesium ions, we have sulfate ion, and many other iron and iron impurities. Alumina is there, and many other impurities are there. So we have to remove these impurities in the further steps. So for that we have reactor. The next step is the reactor. In the reactor we have some reactions. What we add here is we add sludge, and I will tell you from where the sludge comes. This sludge comes from the clarifier, and clarifier is our next step. From the clarifier it is recycled, the brine is recycled here. In the reactor we have the following reaction, and in the reaction we try to add caustic to it, NaOH, and we add soda ash, Na2CO3. Adding these precipitate the magnesium and calcium impurities. So we have calcium as calcium chloride, and we have magnesium as magnesium chloride, that is in the form of salt. So what we add is we want hydroxides of calcium and magnesium. So we add NaOH here, and what is formed, magnesium hydroxide is formed, and NaCl is formed. Here we add soda ash, Na2CO3. So what is formed, calcium carbonate is formed and NaCl is formed. From these gets precipitated, these two gets precipitated, and these are removed in the retention tank. We have retention tank, here what is the purpose is to settle the carbonates and magnesium hydroxide. Some amount is get precipitated. Now to increase further concentration of the sludge we add flocculant. From this step we add flocculant, and we have, after the adding of flocculant, it is a reagent type, that is its main purpose is to increase the amount of sludge, or to increase the concentration of sludge that is getting formed. So here we have clarifier. In the clarifier this is recycled back. That is from the bottom of the clarifier the sludge is recycled, and the main product goes to the next step, which is a clarified brine tank. We have clarified tank. From the clarified tank we have anthracite filters. what we have anthracite filters. What is the main purpose of this filter? These are anthracite coal filter. We have 6 filters. 6 filters are in line, and in these filters, brine, it is like all the 6 filters run individually, so not from one filter to the next filter. So it all the filter are of same use. So this is a filter. From the top we have brine which comes from the top, and this is circulated, and this is a packed bed type of reactor, and this is a constant pressure filtration, not constant. We have 2 types of filtration, constant rate and constant pressure. So here the pressure changes, so this is not a constant pressure filtration, this is constant rate filtration type of filtration process. From the bottom, the ions gets stuck in the coal. So main purpose is to remove the suspended solids from the brine, and from here the brine goes to the tank, and from the tank we have polish filter. In the polish filter we have candles. This is the same as anthracite filter, but here we have coating of alpha cellulose. We have rods, and in the rods we have the filters, and from each filter the brine gets from the bottom. Brine is coming from bottom and it is getting out from the top. We have carbon, these are also carbon filter, and the brine in these carbon filters we have a coating. What is a coating? Coating is called alpha cellulose coating. And what is the main purpose? The main purpose is to again remove the suspended solids from the brine, and then the brine goes to where it has 187 candles, and into 3 we have 3 rods, so into 3 is 561 approx. 561 total number of candles are there in the one filter. We have 3 filters, like we have 6 anthracite filters, and we have 3 clarified polish filter. Okay, from the polish filter we again have a tank, and in the tank, what is the main purpose of this tank? Is to store the filtered brine. So from the filtered brine tank we have ion exchange column. What is the main purpose? So these are again like same. We have 3 column A, and then we have B, and then we have C. We have 3 ion exchange columns, and only 2 are in line. So the material which goes in, if A and B are in line, A and B is in line, and C is in regeneration, then the material which goes in the A will go to B, and then from B we get the output. Okay, we have, this is ion exchange, means these are to remove dissolved solids, dissolved impurities. These are there to remove dissolved impurities. And we have resin, which is a cation based resin. Cation based resin is there. And what is the main purpose? This is, what is the name? Is styrene divinyl copolymer with amino phosphoric acid. This is the name of the polymer, resin. Okay, so the main purpose is to remove the dissolved impurities present in the salt. From here we get, after a certain interval of time, like 10,000 meter cube of flow of brine. When 10,000 flow meter cube of brine goes from here to here, and then from here to outlet, then we assume that the resin is now depleted. So to make again the resin to regenerate, we do regeneration. So like C is in regeneration, so we add some material to C so that the resin gets regenerated. So first step of regeneration is adding to remove the brine first of all, then we do DM washing. DM washing is done, then we add HCl, and then we add caustic. After HCl we do DM washing, then after adding caustic we do DM washing again, and after all this we do brine filling again, and we try to check the hardness of brine is checked, and the hardness should be around 8 to 10 ppb, not more than that. Okay, and we also check in this step after 40 minutes we check the acidity of